So what is mathematics really? Well, we'll start by looking at some mathematical questions, and you might like to press pause and spend a bit of time thinking about them. My question is, what can a human mind do with these? I'm not asking what can a computer do. I'm not asking what can an automaton do. I'm asking, what does the human mind do? And from my experience of human people doing mathematics, I'm fairly sure that the human mind does the following things. It might do some wondering before acting. It might suspect that there are simple ways. It might seek and recognize patterns and relationships, because that's how the mind functions in all aspects of life. It might relate wholes and parts of the questions in some way. It might contemplate similarities across the questions. It would certainly use conceptual knowledge of difference, of consecutive numbers, of distribution, and of decimal notation, as well as using maybe some factual and procedural knowledge, but it turns out it would be quite wise to wonder before acting. It might conjecture about the effects of actions, and it might want to explore more. For instance, in the first one, you might like to think, well, supposing I started with 78 subtract 77. Now, 78 subtract 77 is not a fact that you know beforehand, although you do have the concepts of consecutive numbers and difference to help you. Actually, you probably do know 78 subtract 77 because you spot a pattern and a very well-known relationship. You certainly wouldn't do a procedure. You certainly wouldn't do column subtraction, even if you were very fluent in it. But actually, the question of suppose we start with 78 subtract 77 is quite an interesting one in the context of this first question. Finding the answer isn't the end of what the human mind does. The second one I'll leave you to think about. Here's a question, another one. You might like again to press pause and to think about this. And my question about this is it a problem? Well, if your idea of a maths problem is something straightforward that you do with techniques you already know, then you could start by thinking, yes, this is a problem. But actually it turns into quite an interesting problem, because if the method that you have remembered is to find a common denominator, that doesn't help you much. You have to devise something else to sort this out. And even more so, you have to devise something else when you see the extension question, which I'll show you in a moment. So meanwhile, the idea of knowledge as knowing what, knowing how, and knowing when kind of helps you, but it doesn't totally help you. And here's the next part of the question. Now that's likely to throw you completely, that have 11 as the numerator. Have you got a procedure to do that? Have you got some facts to do that? No, but you've jolly well got an awful lot of conceptual understanding, we hope, about equivalent fractions that might help you with that. And again, once you've got one with 11 as a numerator, it opens a doorway to thinking more creatively about fractions between fractions. The features of what makes these mathematical problems are particular features. Their unfamiliarity, the unusual combination of interacting elements, and significant cognitive load. If you don't want to have those in your mathematical problems, you just set simple questions. Questions that you already know how to answer. What you have to do with mathematical problems sometimes is deal with awkward numbers. It's well known that fractions make things a lot more difficult. Or understand the text of the problem if it's a worded problem. So you have to learn to read a mathematics problem. Once you've understood what the problem is, you have to recognise underlying structures, devise suitable representations, think about meanings and connections, and decide what is necessary. And all of that is about using your conceptual knowledge, and it may be extending your conceptual knowledge. Once you've decided what's necessary, you can remember necessary facts and methods. Or you can remember structures, as with 78 take away 77. It's not a great effort to find the answer to that, really, because you've remembered structures, not facts, not procedures. But you do have to use memory, of course you do, in order to turn your conceptual knowledge into something that you can work with. But that doesn't always work. Very often, if something is a real mathematical problem, you have to derive, devise, or transform known methods in order to solve it. You have to learn to adapt. And the scope of that adaptation depends on your conceptual knowledge, because your facts and procedures are not going to help you with easy answers. So the question is always, what does a human mind do in a mathematical situation? Not what might a computer do, but what can a human mind do? And the complex search systems of the human mind include wondering, context, environment, emotion, intuition, creativity, recognition of parts, wholes, and structures and how those relate to each other, and knowledge and experience of mathematical behaviour. How do we learn any kind of behaviour? We learn it by engaging with it in purposeful contexts with other people. That's how we learn mathematical behaviour. So to learn the mathematical behaviour that is required to solve non-routine mathematical problems, we have to learn through experience of and reflecting on the solving of mathematical problems.